Good morning. Hi, this is Suneel. Today we are going to discuss IoT levels as well as templates. Along with that, we are knowing about cloud computing and big data analytics. These are the topics which we are going to cover today from principles of Internet of Things. Before entering into this particular topic, I just want to tell you an overview about what exactly cloud computing was and what exactly big data analytics was and what was the major use of these IoT levels and templates which we are going to use in this particular principles of Internet of Things. Yeah, have a look here in this particular introduction to Internet of Things. Today we are going to discuss about cloud computing. What exactly cloud computing was? Before knowing about computing, we need to know about what cloud was. Cloud was the thing where we are going to store our particular data, where we are going to store our database. Over the internet, we are going to store bulk information into the cloud. The service which is provided by the cloud, which is officially called as cloud computing service. And coming to big data analytics, data analytics is the thing which is going to perform on the raw data, which is going to give you a valuable insights on the operations performed on the raw data. And here we are performing big data analytics. We are comparing with big data sets and performing on those particular raw data and providing a valuable insight on the things which we are going to analyze. And along with that, we are knowing about different kinds of communication protocols. Along with that, we are knowing about different kinds of embedded systems which are included and different kinds of IoT levels, level 1, level 2, level 3, level 4, level 5, level 6. There are total 6 different kinds of levels which are going to be treated to each one of a specific IoT domain like home, smart home environment, smart city environment, smart environment, smart energy systems, smart retail systems, like that. Every level is going to support one kind of specific domain, and along with the template, today we are going to discuss. Now we'll enter into this particular thing. Have a look. As I told you in the previous classes also, from this particular module, we are knowing specific things such as what exactly the concept of Internet of Things was, what exactly the characteristics are, and we are going to familiarize with the IoT protocols and the communication models along with the application programming interfaces which we discussed in the previous class. In today's class, we are knowing about the IoT enabled technologies along with the applications which are specified in that specific domain. For that specific purpose only, we are dealing with cloud computing, big data analytics and different kinds of IoT levels. At the end of the topic, you guys are aware about the you are going to identify and analyze the specific domains which are related to IoT, and also you are going to know about what cloud computing was, what big data analytics was, and what are the different kinds of levels which are presented in this particular IoT. Have a look here. First, we will start with discussing about cloud computing. Cloud computing, to be frank, I'll say in a one word, it is an on-demand availability of computer system resources which are going to be stored in cloud, like such as without data interaction, nothing was possible. Through the internet only, all the data is going to be retrieved and all the data is going to be saved into the cloud. And here in this computing and storage resources which are provided in the cloud are having multiple kinds of users who are using this particular cloud throughout the world. And also here there are some specific set of services which are provided by the cloud as per the requirement of the users. Here the users are assigned with virtual resources and also they can run on top of the physical layer. And to be precise, this particular cloud computing, it is a combination of both software as well as hardware. Here the computing resources are going to be delivered to you with the help of internet only. That's what I have informed you in the starting itself. The cloud computing is a service through the internet only. We are able to store the data, we are able to grab the data, and here there are three different kinds of services such as IaaS, Information as a Service, Platform as a Service, SaaS, IaaS plus SaaS, Platform as a Service, Software as a Service. These are the three different kinds of services which are provided by the cloud. Have a look. And there are, as I told you, there are three basic service models which are going to be offered by the cloud computing. And here these particular categories which are going to be based on the services which are provided by the service provider. For suppose if you opted for IaaS, which is an infrastructure as a service, and the second service is PaaS. Here the provider is going to provide you platforms as a service, and coming to software as a service, and coming to these three basic services models which are enlisted in our cloud computing. And from the cloud service provider, if you opted for IaaS, only you are getting infrastructure as a service. You are provided with the infrastructure. No need to let's take a real-time example. First, suppose you have established a company. In that company, you need to set up a server. For setting a server, it is going to take lakhs of investment. For that particular purpose, if you approach a cloud service provider, he is going to provide you the infrastructure which is required for you. With that particular service, you are going to fulfill your needs. For that purpose only, cloud is providing these three different types of services according to the client requirements. And the same, such as platform as a service, there you are going to get infrastructure and also platform which you guys are working on. To purchase a specific licensed software, it is complicated for the new startups companies. For that specific purpose, the cloud providers are going to give you platform as well as software as a services. For this particular purpose only, I narrated you three different kinds of services which are provided by the cloud. The first one is infrastructure as a service, the second one is platform as a service, and the third one is software as a service. Now have a look what exactly these services are. Coming to the first one, infrastructure as a service. Here in this particular service which is provided by the cloud providers who are existed in the market, take an example, Amazon. Amazon is also a cloud service. Take Google. Google is also a cloud service. Here the first service is infrastructure as a service. Here the technology is going to be highlighted, like whatever the technology which is used by the specific company, as per your demand, the service is going to be served to you. And the specific users who opted this service for infrastructure as a service, having a provision for computing their particular things as well as for storing their particular resources, whatever the resources which they are going to compute on the infrastructure which is provided by you, they are going to compute the things as well as they are going to store the particular information into the cloud itself. And this particular resource is going to use virtual machine instances and virtual machine storages. And here user is capable of starting new things, and also he is able to stop, and also he is able to configure, and he is also able to manage the things by using these virtual machines as well as this virtual storage. Whenever he doesn't want to store his information, he can stop the proceedings. Whenever he wants to configure the infrastructure which is provided by the cloud service provider, he is going to stop the kind of services. So for that purpose only, here it was mentioned that in this infrastructure as a service, user can stop at any time if he wants, and also he can start at any time. In the same way, he can configure and manage the things. And here the users are going to deploy the operating systems which are applicable, which are used by him along with the applications which he provided in the cloud. And here one major thing which is there, here in infrastructure as a service, they are following the virtual resources by the end users, which are build based, like a pay as you go, pay per the things which the cloud service was provided. For suppose, take an example, like you are opting for a Airtel service provider, and for that particular Airtel service provider, I requested for 100 MB of data. That 100 MB of data is provided to you. Out of that 100 MB, I have used only 62 MB. For this 62 Mbps only, we are going to be billed. That is what pay per use paradigm. This is what you have used, which kind of service. That is what infrastructure as a service. There are some advantages as well as there are some disadvantages. These are going to be majorly used by the system administrators. What advantages are? Here we are having enhanced scalability and flexibility. As I told you, we are very much flexible with this particular kind of services called infrastructure as a service. And also we are having enhanced scalability of the resources which we are going to use. For that purpose only, the cloud service providers are giving this particular environment. And along with the advantages, there are some disadvantages of using this particular infrastructure as a service, which is security issues, security delays and network delays. Why? Because the entire service, the entire infrastructure was provided by the cloud service provider. If there is a network issue, automatically network delay will be there. Automatically service is going to be delayed. Automatically security concerns are there. Why? Because the entire service was provided through the network only. Whatever the data which we are retrieving, whatever the data which we are analyzing from the cloud service through the internet only. For that purpose only, these are the three major disadvantages which we are going to face whenever we opted for a service called IAAS, which is infrastructure as a service. And the best example for this infrastructure as a service was Amazon Elastic Compute Cloud, which is AWS EC2, which is Elastic Compute Cloud, which is a web service which is provided by Amazon. And by using this particular service, you are going to literally source our particular data by building servers in it. And we'll see the second service, which is platform as a service. And this was the service which is going to give you an ability for developing as well as for deploying the applications which are used by multiple tools, and along with the application programmer interface and along with the services which we are going to get from the software. And here we are going to be provided with operating system, along with programming languages, along with application program interface, and also server array is going to be presented, and also database is going to be presented. If you see in this platform as a service, we are getting services like operating system and programming language, which is going to be used by the client, and also APIs, which are application programmable interfaces, which acts as an interface between the server and client, and also a server is provided from the provider and database is provided from the server. These are the kind of services which are going to get from the end of cloud server to the client. And here there is no choice and there are no virtual machines. User can build the things, user can compile the things, and user can run the programs in which way he want to develop the applications. And here in the scenario where the applications are going to be developed with a particular platform, and by keeping those things in the mind, the client has to opt for this particular kind of services. And coming to the thing, and here users are responsible for the data management as well as the application resources also. And here this particular environment is multi-tenant environment. Why? Because multiple clients are going to work in this particular environment. Why? Because for suppose treat with a real-time example. I was working in a company where my company has opted a service called platform as a service. In my company, there are n number of employees. Out of n number of employees, there are 4 employees who are working as a team for some specific project. Out of 4 members, 1 person is compiling the code, the other person is running the code, and some more person is extracting information from the database. This is how the things parallelly, that for that purpose only this particular thing can be officially called as multi-tenant environment. And see the advantages and disadvantages of using this particular service. By using this particular service, the advantage was it is very scalable and it was very cost effective, and it is very much faster compared to the market of developers, and it is very easy to develop the web applications. Why? Because we are getting the operating system, we are getting the software, we are getting the APIs, we are getting the database. Everything is provided by the service provider. So it is very easy for developing the web applications. In the same scenario, by in this service also, we are having disadvantages such as must use the languages which is provided by the provider, service provider, and also we are not using any kind of virtual machines or any kind of storage devices. Why? Because everything was provided by the service provider. In that scenario, no virtual machines, no storage devices are there with us, and there will be a vendor logged in. Why? Because he is the one who is providing service to us. So for that purpose, vendor is going to log the things as per the security concerns. Here, it was used by software developers. This particular service is going to be opted by the software developers, whereas the infrastructure as a service is used by the administrators. Coming to the example, Google Application Engine, AWS Elastic Beanstalk. These are the best examples which we can treat for this particular service. And coming to the next one, which is software as a service. This was the third service which is provided by the cloud. Basically, all these services are going to be provided by the service provider, which the client has been opted for. According to his requirement, he is going to opt for the service. And coming to the third service, which is software as a service. Here, this service is going to use a complete software application where user is going to interact with the application by himself itself. Here, see here, SaaS provides the user the complete software application or the user interface to the application itself. This is how SaaS is going to give you the service. And coming to the thing, here the cloud service provider, officially we can call him as vendor, and who is managing the underlying cloud infrastructure. Why? Because in cloud there was a lot of infrastructure which was presented, and the person, the vendor who is providing service to us, is going to manage the things such as servers, networks, operating system, storage, application software. And here the user is not aware of this particular underlying architecture which is managed by the vendor. And here we are not going to install any kind of software into the PC. And here whatever the applications which are going to be used by us, those are the client interfaces which are browsers. And coming to the thing, it is platform independent, such as Mac, Windows, Linux. In any kind of operating system, we can use this particular software application as a service. It is platform independent. And the advantages and disadvantages which are related to this software as service. In this software as a service, we are having an advantages like this: universally accessible from any kind of platform. And here it is excellent for collaborative work. As I told you, as I mentioned you in the previous example, in any company, if they opted for this software as a service, we are going to work as a collaborative teamwork, and where the vendors are going to provide the modest software tools and also allows multi-tenancy. And there are some disadvantages, like as we discussed in the previous two services. Here in this service also there are some basic disadvantages such as less flexibility, and we may face browser issues. That was the second concern. And there will be a vendor lock-in, like the previous one, which is platform as a service. And here this was going to be used by the people called end consumers. And the best example for this particular service was Gmail, online office, Google Documents, and online converters, such as we guys are going to use online converters through online, right? These are the best examples software for software as a service. These are the three different kinds of services which are going to be provided by the service provider, cloud service provider. Now I will take a real-time example and I will let you know how IAS is going to function, PAS is going to function, SAS is going to function. Consider this particular example on screen which is shown to you. This is related to IAS, infrastructure as a service, and this is related to PaaS, platform as a service, and this is related to SaaS, software as a service. And if you observe the scenario, here the things are going to be managed by the vendor, and also you are also going to manage some particular things as per the service. The things which we are managing and which vendor is managing are going to change. If you observe carefully, in infrastructure as a service, what are the things which are managed by the client? The client is going to manage the data, the applications, the runtime, the middleware, the operating system. Whereas vendor is going to manage virtualization, servers, storage, networking. These are the things which are managed by vendor whenever it comes to a particular service called infrastructure as a service. Whereas if we entered into platform as a service, the things which we are managing are only data and applications. And the remaining all things, runtime, middleware, operating system, virtualization, servers, storage, networking, all these particular things are going to be managed by the vendor only. Whereas if you enter into software as a service, only thing which we are able to manage being as a client was data. The remaining things are going to be managed by vendor only, like as I shown here. And this is how the things are going to be in the particular service. Consider the same thing. I'll take a real-time example, pizza delivery. See here, pizza as a service. On thing, what the traditional premises which we have on premises was made at home. This is for take and buy. This is for pizza delivered, and this is for dine out. In these scenarios, traditional on premises, if you use that particular traditional on premises mechanism, we are having a dining table, we are having soda, we are having electrical gas, we are having oven, we are having fire, we are having pizza dough and tomato sauce, topping, cheese. Everything will be managed by us only. Why? Because it is related to traditional service. Whereas in infrastructure as a service, the vendor is going to manage pizza dough, tomato sauce, topping, cheeses. Where being as a client, I am managing the dining table, soda, electrical gas, oven, fire. These are the things. Whereas coming to platform as a service, I am going to manage dining table, soda only. The remaining things such as electrical gas, oven, fire, pizza, tomato sauce, topping, cheese are going to be managed by the vendor. This is how the things are going to be in platform as a service. If you opted for software as a service, which is dined out service, you are going to completely, you are not managing anything. Simply you are going out and you are ordering for that particular product, you are utilizing it, which is for that purpose only I mentioned dined out process, which is software as a service. If pizza is, you ordered pizza on an app, that kind of service is platform as a service. Take a real-time example. For suppose, if I want to cook pizza, every ingredient was there in my house, means that will be called as traditional premises. If I wanted that particular pizza dough, tomato sauces, toppings, cheese from vendor, I have purchased from some DMart or else whatever the store it was. The remaining things are available in my home. The remaining things which are shown in green color are taken by the market, right? This is infrastructure as a service. I am utilizing the infrastructure which is provided by the vendor. And coming to platform as a service, I am utilizing only a particular data, what exactly I need, and by using that particular software application, I am ordering pizza. That's it. The remaining part will be taken care by the vendor, such as electrical gas, oven, fire, pizza dough, tomato sauce, topping, cheese. Everything will be prepared by himself, and he is going to deliver you the concerned thing. Whereas if you opted for software as a service, the entire things are going to be managed by the vendor only. This is how the services are going to be get by using cloud computing. As I told you, there are three different services. One is infrastructure as a service, second one is platform as a service, third one is software as a service. These are the three services which are provided by the cloud. Now we'll enter into big data analytics. What big data analytics? Before entering into big data analytics, we need to know what big data was. As I told you, big data, it is a collection of data sets where whose volume is going to be considered with multiple velocities, variety of data is going to be there. So large it was, and it is very difficult to store and manage, and also for analyzing the things by using the traditional database as well as by using the traditional data processing tools. And coming to big data analytics, here we are involving different kinds of steps such as data cleaning, data mining, which is kind of wrangling, and also data processing, data visualization. These are the four different kinds of things which are involved in big data analytics. Coming to this big data analytics, our main intention was to extract the meaningful insights. For suppose, take a raw data, like take some alphabeticals such as H, I, comma E, comma L, O. There are 5 alphabets which are taken. These are raw bits. By using these raw bits, if I framed a variable inside, like hi, which is a variable inside, hello, which is a valuable insight. By using like this, a meaningful insights has to be presented to you, such as hidden patterns, unknown correlations, as well as the market trends which are unpredictable. Today the market rate was so and so, and the next minute it may drop or it may go higher. Like this, market trends are going to be managed by this particular data analytics, and also based on customer preferences, we need to analyze the things like this. In big data analytics, the things are going to be, as I told you, the major characteristics for this particular big data was volume, velocity, variety. Volume means there will be no limit. We can take n number of data, n number of volume of data, which is going to be analyzed by our big data analytics for scaling the data, and also very difficult to store this particular data into the things. Why? Because the volume, the size of the data was very big, and whenever you try to process this particular data by using some specific data tool, it is very hard. And in the same way, by using this volume of data, we are going to process by using traditional databases as well as traditional data processing techniques also. And coming to velocity, velocity is the thing where the data is going to refer, how fast we are going to generate, and also how frequently it is going to be varied. This is how velocity was, how fast we are going to generate and how frequently it is going to be varied. This is how we are going to verify the velocity. Coming to variety of data, for suppose take an example, real-time example. You are having an electronic gadget. In that particular gadget, there is a variety of data. Some people may have images, some people in the same gadget, you are having images, you are having PDF documents, you are having videos, like that, audio information, like multiple things, multiple kind of variety of data will be presented in your particular database. On all the variety of data, I need to perform this particular big data analytics. See here, variety refers to forms of data. As I mentioned you, text data will be there, image data will be there, audio data will be there, video data will be there, and sensor data will be there. Sensor data which is related to our IoT. Right? Sensors in IoT, as I told you, every device is having a sensor in it, which is going to sense the information and pass through actuator to your concerned device. This is how we are going to analyze the scenario. Coming to big data analytics, what are the advantages which has to be taken? See here, we are having a better decision making, and the cost is going to be very low, and we are going to purchase multiple products as well as services. And see, there are some examples which are narrated to you. For suppose, by using our IoT system, smart home management, smart home advanced system through our IoT, and here whatever the IoT devices which are placed in a smart home are having some sensor data which is going to be generated by that particular devices. That is called sensor data which is generated by IoT devices. And also machine sensor devices which are going to collect sensor information from industrials, and also health and fitness, like your smart watches which are going to give you the heartbeat, which are going to tell you how many steps have you tracked, how much calories of fat which has burned by you. That entire things can be managed by IoT devices. Coming to the next thing, which is data generated from the IoT devices by using locations, tracking, all these things can be done. And the next one is data generated by retail inventory monitoring systems, such as for suppose take an example, real-time DMart market. First of all, there are n number of volume of information which is presented in their database. Every day they are going to sell some products and they are going to buy some products. The entire information, retail inventory monitoring systems are going to be taken care about of it. And see here, what are the different communication protocols which are going to helpful, which are going to be backbone for our IoT devices. These are the protocols which is allowing the devices for exchanging data through the network, which is internet, and also we are assigning different kinds of informations as I specified you, and also every data is encoded with a specific addressing scheme. As I told you in the starting itself, every IoT device is having an unique IP to that particular device, and here whatever the data which you are addressing, it is going to reach towards the source to destination, and also it includes the sequential flow, and also it is going to control the flow of transmission of data, and also without any kind of lossages by using these communication protocols we already discussed previously. And see here what embedded systems are. As I told you, embedded system is a computer system where our computer hardware and software are embedded to perform specific tasks. For that particular purpose only, embedded system is going to be used. Embedded system, if anyone asks you what embedded system, simply you say that it is a computer system which is having both hardware and software, which is utilized by us to perform a specific task which is given to us, which is simply embedded system is computer system. What exactly a computer system consists? Both hardware things as well as software things in it. Which, for what purpose we are using? To perform a specific task. That is what embedded system is. The key components for these embedded systems are like our memory, which is really, the memory is a random accessible memory, read-only memory, or cache memory, whatever the things, and also network units such as Ethernet, Wi-Fi. See here, yeah, these are the memory. And this is about the networking units which are presented in our computer, and also the devices such as keyboards, monitors, display, and also storage devices like flash memories. And also this particular embedded system is also consists of DSPs, which are digital signal processors, and also the graphs which are going to be identified, and also the application specific programmers. These are the things which are going to be existed in the embedded system, which is officially a computer system. And by using this particular embedded systems, you are going to be less low cost miniature devices such are going to be digital watches, and the devices digital cameras, POS terminals, which is like bills, online bills has been taken, vending machines, applications. All these different kinds of machines comes under our embedded system, which is performing a specific task. POS machine, which is used for swiping the cards, vending machines which are used for taking some particular product, appliances which are going to perform a specific task. If you take washing machine, it is going to wash your clothes, which is operated by a embedded device. This is how the things are. And see the different kinds of IoT levels which are deployed in multiple ways. Every IoT system which it should have the following components, then only we will call that particular system as IoT system. It should comprise the following components such as device, resource, controlling service, like that. Coming to device, what kind of device we are using? Either the device is allowing identification, either the device is having sensing sensors which are connected to it, or whether the device is having an actuator to it, and also whether the device is going to be controlled by remote monitoring capability or not. These are the things which has to be checked before installing that particular device. Every characteristic as unique. See here, identification, unique IP. Remote sensing, sensor is the thing which is going to sense, and actuator, which is the things as per the sensing data. Actuator is the one which is going to transfer that particular data to your device. And remote monitoring capability, user should be capable to monitor that particular device by sitting anywhere in the world. Like that, the device capability should be. And coming to resources, what are the resources which are provided, such as software components which are existed to that particular device. Resource which may also include the software components which are going to enable you the network access, and such as controller service. And in this controller service, we are having a native service which is going to run on the device whenever we are interacting with different kinds of web services. What web services? Web services are nothing but which are we are getting from particular web service provider. See here, coming to IoT levels and deployment templates, and coming to the first thing which is we have to discuss before this IoT level and deployment templates are database. database was the thing where we are going to store our information, either which is related to us or which is related to our company, which is going to be stored into the cloud, which is generated by the IoT device. We can enter the data manually, or else whatever the data which is sensed by the particular IoT device are going to be stored into your cloud. And what web service was, as we discussed in the previous topic also, web service is a server which is a link between the IoT device and the application database, where you are analyzing the components. For suppose, take an example. In our smart home, I have installed a CCTV camera, which is an IoT device, and that particular IoT device has to sense the information which has to be recorded. Whatever the thing happening in front of the camera is going to be recorded, and that particular data has to be forwarded to the through some particular application database, and then only we'll analyze that particular. This is what web service was. It is going to be implemented by using few things such as HTTP, Hypertext Transfer Protocol, and REST principle. REST is a kind of service which we already discussed previously. REST API, REST application programming interface, and also we can use this WebSocket service, which is officially called as web protocol. And also analyzing component, as I told you, it is the one which is responsible for analyzing the data which is extracted from the IoT device. And coming to application, as I told you, an application is required to the user to monitor these particular IoT devices and to control the things. These are the things which has to be considered. See here, IoT level 1. Here, in this level 1, it was the system which is designed uniquely for a single node or a single device which is going to perform sensing and or activating. It is going to sense the information or it is going to activate the information for storing the data and for performing analysis, and also to identify by the client by using that particular application. It was a low cost and low complexity solution which is designed. And the best example is home automation by using REST API. If you observe the scenario, see here, this was the local and this was the web service which is located between. This was the device, and user is controlling the device by using that particular resource and also the particular thing. See the best example, home automation system, how the things are. This was the control panel which was established. This was the electric light which is officially called as IoT device, and this was a smoke detector which is going to identify if there is any smoke which is caused due to electrical power. It is going to be identified. Sensors were for mailbox which is going to be dropped. If there is any mail which is dropped by the postman at the outside of our house, the sensor is going to detect that you are having a mail. And intrusion detector, if anyone tries to break our locker, automatically you are going to get a message. You are going to be alerted. If someone has pressed your door alarm, you are going to get an alert. By using these many kind of IoT devices, you are going to be alerted. This sprinkler, it is also an IoT device. In which scenario these sprinklers are going to be used? If there is any fire situation which is happened in your house, in your options, automatically this sprinkler is going to sense at a particular maximum heat Celsius. It is going to start sprinkle water and avoid the collision which is going to happen in our home automation system. That much advancement is there by using our IoT. This was the first level, which is home automation system. And coming to the level 2, we are going to store the data in cloud, and also we are using the application which is related to cloud-based. In the first one, we have used the device independently, only one device. Whereas here, whatever the device which we have, entire data is going to be stored into the cloud, and also we are using the application which is related to cloud. And this is suitable for such as big kind of organization. Take an example, smart irrigation. Like smart irrigation is the one of the specific domain which is related to our IoT. And by using this smart domain, how the things are going to be happen. See here, locally we are having a monitoring node which is set up in our particular field, and this was the device, and this was the resource, and this was the controlling service. In between, we are using REST API, which is a REST application programming interface. With that particular interface, by using our control service, which is an application which is provided by the web resources, and we are communicating with the web server, and as per our request it is going to search the database and it is going to retrieve through that particular app. This is how the things are going to be communicated in this particular service. See, this is how the level 2 smart irrigation automatically. See, the sensor has been placed in form of sprinkler. According to the temperature, moisturizer, according to the health of the plant, everything was connected through internet only. If our soil is wet, automatically it will sense this much moisturizer is there in our irrigation. Automatically start sprinkling water to the plants. So the health will be improved. It will maintain certain temperature for some kind of fields. In that scenario also, our IoT device is playing a major role in level 2, which is compatible for smart irrigation. And we'll go for level 3, which is majorly suitable. And here in this system also we are using single node, and also we are going to store the data, and that particular data is going to be analyzed by the cloud here. And here whatever the data which we analyze is going to be computationally intensive, and it will be in a real-time factor. For suppose, take an example, IoT system for tracking package handling, which for suppose, take a real-time example. I am traveling through a plane. My baggage has been surrendered to the air department, and to that baggage they have set up with some particular barcode, and by using some particular RFID to that particular devices, we are going to track our packages by using that particular thing, where exactly our package was. And also the controllers sometimes may sense the data to the cloud, and by using this particular scenario, see here, whatever the monitoring node which we set up to that particular device, with the help of this REST API communication, it is going to connect it with the database, and we are knowing that where exactly the data was. In this analysis which is performed on the cloud, it is going to trigger itself whenever the particular application has been reached to a threshold value. Automatically it is going to consider. This is the best example for level 3, which is tracking packet handling. Whatever the packages which are outed, you are simply monitoring by using a particular application, which is Amazon. You have ordered for a product. These are the sensors which are alerted, which are accelerometer, which is going to sense the movement and vibrations which are presented, and gyroscope, which gives orientation about the package information which is going to be transported. These entire things can be done with the help of WebSocket, which is a service which is going to be used because for sensing the data which is going to be sent in a real time. This is how we are going to use in level 3, which is the best example was tracking package handling. And coming to the 4th level, in this 4th level, till now we have used either a single node or the data which is uploaded to the cloud in second, and coming to the 3rd one, single node along with the data uploaded to the cloud and data analytics. Coming to the 4th node, we are allowing multiple nodes which are going to perform local analysis. And in this particular thing, whatever the application, whatever the cloud-based scenario was, whatever the nodes which are existed, if you observe in this particular level 4, we are placing multiple nodes. Until now, in all the above 3 levels, we have placed only a single node. From that particular node, whatever the information which is sensed by the sensors are recorded, and on that recorded data, we have performed data analysis. Now, we are placing multiple nodes, and these 2 multiple nodes are connected to the cloud server. By using this particular REST API configuration, which is a REST application programming interface, which is going to communicate with our local devices and also the cloud, which is a database. And here in this level 4, which is majorly suitable for multiple nodes, and also the data whichever involved, we are performing data analytics. And this is best for noise monitoring system. Have a look how the noise is going to be monitored. Sound sensors are going to be used here in this particular environment. These are the sound sensors which are placed in an environment. If there is any noise monitoring, the entire things can be taken care. The entire data is going to be captured. And see the level 5 of data. And here level 5, we are having multiple end nodes and only one coordinating node. And in this end information, both sensing as well as acquisition will be done. And here, whatever the coordinator who is performing between the end nodes and sends the information to cloud. See here, there is a coordinator who is going to handle these multiple nodes. In these multiple nodes, coordinator is having the information about the end device and the resource and the controller device, and also the endpoints is having the same kind of information which is going to be communicated by this REST API. If you observe this scenario in all the IoT levels, until we discussed in the first level, we only deal with a single node, and in the second level, we only deal with the cloud, how the data is going to be recorded from the sensors and how it is analyzed. And coming to the third node, we placed a single node as well as the communication. Whereas in fourth level, we have placed the multiple nodes. Whereas here, we are placing a coordinator also. That was the difference between level to level. And this particular level is majorly suitable for forest fire detection. And in this forest fire detection, if there is any fire unwantedly happen in the forest due to the heat or whatever, cloud-based application by using or visualizing the data things through the sensors. So there are some sensors which are going to be placed in forest like this. They are going to sense and they are going to give you the report. If there is any fire which fire burn, automatically it will alerts the concerned forest department to take care, and it is going to detect a forest fire in early stages. Now, whatever the sensors which we are placing in that particular forest are capable of detecting temperature, smoke, weather, wind speed, and also speed of fire spread and the flame length. Why? Because in forest there are huge number of trees which are dried. According to the fire flame level, also we need to carry the anti things such as carrying multiple water dispensers to avoid that particular thing. The best example for level 5 was forest fire detection. And this last level, which is level 6, which is having multiple independent end nodes and also a particular controller which is going to perform and sense the information which is going to be uploaded into the cloud. And here we are going to analyze the data, whatever we extracted from our sensors, and that particular data is going to be stored into the cloud database. And here the results are going to be virtualized by using our cloud-based applications. The best example for this particular level was weather monitoring system. And see here, this was the cloud service, and this was the centralized server, and these are the multiple nodes which we are having a connection with this particular web server. By using the same REST WebSocket communication protocol system, we are communicating between both our devices as well as to the cloud. In all the relations, we are only communicating with locals and also the cloud. And this particular level 6 is best example for weather monitoring system. See here how the weather monitoring systems is going to be use our particular IoT level 6. See here how the devices has been based, how they are going to detect the things, how they are going to detect the wind, how they are going to detect the speed of solar radiation, how the temperature is going to be detected, is there any humidity which is presented, is there any pressure, is there what the soil moisturizer. These are the parameters which are going to be taken care by the weather monitoring system. See here, what are the parameters? Wind speed and direction, in which speed the wind has been, in which direction it was, and what was the solar radiation which is presented in the nature, and what was the temperature, either it is air temperature or water temperature or soil temperature, and what was the relative humidity, and what was the pressure which is presented in it, and what was the soil moisturizing capability. These are the things which are considered as the parameters when this particular level is going to be initialized, which is officially called as weather monitoring system. That's it, guys. We'll meet in the next class with specific domains which are related to this particular IoT field, which is domain specific IoT, such as the same things, smart home, smart weather system, smart monitoring, smart health, smart what we call retail systems, everything. All the specific domains we'll discuss. That's it. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.